All right, let's get this simulation set up here. Again, we need to put some labels in, so I need to know that what my H0 is, and that's, let's see, so I'll say P equals, and again for this one we're assuming the population on the whole is 0.059. Now I can make this one right justified and this one here left justified, and see, when you look at it, it just looks a little nicer. And in the project directions, instructions, all that stuff, I suggest you might want to make that yellow, just because that's something you could change. You could decide, oh no, it's not 0.59, it's 0.55, or 0.60 or whatever. But so that's kind of one of my assumptions, one of my inputs, and so I have that there. Now we need to keep track of our trials, so I say trial, and I'll probably want to center that. Now here, I hit 1 and I drag down, and so there's 5, 13. Well, we want to do 1,000 trials, so to keep track, I'll just drag down. I watch my counter. I can also watch the numbers on the left because they're about the same. They're one off. Almost there. Whoops. Let's see. 1,000. Okay, so there's 1,000. Okay, and then I need to keep track of the total reported bias, total surveys that reported bias. Now this one I probably need to widen a little bit, and again I probably want to center it so I can see it a little better in this case. And to get total reported, well, I'm going to need a formula. Before I do that, so I know where to go in my formula, I'm going to put my observations, and each observation is a survey that's returned, and there were 33 surveys returned, so 1, and enter, and then I'm going to drag this over so I can keep track of those. I need 33, so I come over here and get to 33. Now there are a couple things. I probably want to center all these columns, but they're also unnecessarily wide, and so I'm going to grab these and highlight them, and I can go all the way over here to 33. Do a right click and column width. There's probably column width up in this ribbon somewhere, but I've never looked for it. And with just these numbers, I bet I can go as small as 0.3 inches. And I say OK. And yeah, that looks fine. But also, these are all over to the right, so while I've got it all highlighted, I'll put in center. Okay, now I have this. Now I can't quite see it all, but if I shrink down the size of the trial column, and at least I shrink down that column B, and I shrink down that one a little bit, at least for now, until I start adding other things, I can see everything. And another thing I could do, see, I've got mine expanded down here. It says 130%, just so it's as big as it can be, and you all still see the whole thing on the screen. I could take it down to 100%, and it would look that small, but I'm going to take it back up to 130. Whoops, I hit 140. Okay, 130. Now, I can see how far I need to do my sum, and what I'm going to do is put zeros and ones in here. A 1 meaning the survey was returned with some sort of bias, any bias, and a 0 meaning no bias. And so if the ones mean bias, then I can count how many of these 33 return surveys indicated some sort of bias simply by summing up the numbers here. I can, if there are 15 ones and I sum that up, I'll get 15. And yeah, that's the right answer. So here I'm going to say equals sum and highlight all the way over to 33, so it goes from E2 to AK2. Close that parenthesis and I get 0. Now it could have given, a different spreadsheet might have given an error because there are no numbers there, but in this case, in this spreadsheet, if there's no number and you're saying sum, it assumes that there's a 0 there. That's good to know because, well, maybe that matters in other things as well. Now I can, here I can double click this right hand button and fill everything in below, but actually I'm going to do one trial first all the way through and then just fill in everything down below. So here I need to say equals, and in this case I need a conditional and I'm using a random number with that. So I say if, and that's a spreadsheet command, and that's why I needed, whoops, I don't know what I just hit there. There we go, parenthesis. So if is a spreadsheet command that, or spreadsheet function that allows me to do a test on something, decide whether or not something is true, and then I get 2 spots, one for what I do if it's true and one for what I do if it's false. And so what we want to do is generate a random number. Well, that's another spreadsheet function. So I say rand. It's a lot like rand between, but instead of the rand between that generates a random integer, like 0, 1, 2, 3, 4, 5 between whatever 2 numbers I give it, rand generates a real number in the interval 0, 1. So it could give me 0.32, it could give me 0.85, and so on. But this is a random number between 0 and 1, uniformly random, so that every number has an equal chance. And so if I generate that, I'll get a number between 0 and 1. Okay? So what I want to check is that random number less than or equal to 0.59. Now I actually could have just gone with less than, and technically that actually might be better. I think in your instructions I go with a less than or equal sign. Theoretically it shouldn't matter whatsoever. You can look at the calculus and statistics and all that, whether I use a less than or equal sign, because it's a continuum. Now with computers, yeah, it can matter, and possibly technically I ought to use just the strict inequality, and the reason for that is I believe the rand command can generate a 0, but it cannot generate a 1. So when we say a random number between 0 and 1, I believe that this command could return a 0. Now it's highly unlikely because the probability of that is basically 1 out of infinity, but but it could, and partly because it's a computer, there aren't actually an infinite number of numbers to choose from. And since it doesn't include 1, and again, I might be wrong, but you know, I've mentioned this before, don't wreck a good story with facts. Since it might be 1, since it can't be 1, then really probably to get 59% of the numbers I would use a strict inequality, and you know, for this. But like I say, don't wreck a good story with facts. You know, this gives us the idea. 59% of the time, this random number should be less than 0.59, less than or equal to 0.59. And so if it is, that's 59% of the time, I want to say that that meant that was a survey returned with some sort of bias. Then if it's the rest of the time, so a number bigger than 0.59 or 41% of the time, I'll return a 0 and say, oh yeah, that person returned it showing no bias. Close that parenthesis, hit enter, and that one's a 0. Now I can pull that over to the 33, and what we have there are a bunch of 1s and 0s, and there were 21 of them. Isn't that nice, right? And now I can copy and paste any sort of way to fill in down here. The easiest is to highlight all of that and then double click on this, and there we go. There I have, I've just generated 33,000 numbers in here just like that. That was nice. And summed each trial up for 1,000 trials, and you see these are all the numbers. Okay, so that is our simulation of this thing, and so we'll stop this video here, and we'll do another video on making the frequency table and generating a nice bar chart. Bar chart again because these are discrete here. These are not these. Sorry, these total reported numbers. They're discrete. I mean these are too, but that's not what we're going to graph. We're going to look at total reported. We're going to get those frequencies. But again, those are integers, so that's a discrete thing, and so we'll use a bar chart. Alrighty. So let's call that good for this video.